the question is, for a nucleus AZX having mass number A, atomic number Z, the surface, there are 4 options given: the surface energy per nucleon, Coulomb contribution to the binding energy, the volume energy, decrease in binding energy proportional to the surface area. While estimating the surface energy, it is assumed that each nucleon interacts with 12 nucleon. So the formula of binding energy is EB should be equal to AVA minus there are 5 terms. The first one is volumetric term, second is surface term, third one is asymmetric term, fourth one is Coulomb's term, and last one is pairing term. All these terms comprises binding energy. You need to remember this one. So for the surface energy per nucleon, that is given as A1 into A to the power 1 by 3. So this is correct. The Coulomb contribution to the binding energy is minus A2 Z into Z minus 1 to the power A to the power 4 by 3. It is not correct because given as A to the power 1 by 3. So this one is the question given as the surface energy. Which of the following option is correct? The surface energy is given as per nucleon, but this is the total surface energy, so this option will not be correct. The Coulomb contribution to the binding energy is, this should be A to the power 1 by 3, so this is not correct. The volume energy, this one is correct because this is clearly given. While estimating the surface energy, it is assumed that each nucleon interact with 12 nucleons. Nowhere it has been mentioned that each nucleon will interact with 12 nucleons. And the fourth one is decrease in the binding energy is proportional to surface area. So if this is surface, binding energy will decrease if this is increased. So obviously decrease in binding energy is proportional to the surface area. So this is also correct. So C and D are the correct option. Correct option. So this one is the correct option. So this is a question of, in a constant volume calorimeter, 3.5 gram gas was burnt in excess of oxygen, 298 Kelvin. The temperature of the calorimeter is given. Given the calorimeter constant, you need to calculate the enthalpy of combustion. So enthalpy of combustion means whatever the energy that will release from the burning of the gas, that will increase the temperature of the calorimeter. The temperature of the calorimeter will increase by Q is equal to M into S. M is Q is equal to MS delta T, or basically S into delta T. So S is how much? 2.5. Delta T is 0.45. So the total value coming is 9 by 8. Now this energy is released from the burning of this gas. So, and you need to find out the enthalpy per mole. You just apply Q is equal to mole is so I am assuming the enthalpy per mole is X. So this is the number of mole and this is the enthalpy per mole. Now equate both of them. This is coming 1 by 8. This x by 8 plus 9 by 8 should be equal to 0. So x is equal to minus 9. Question number 4. 1 mole of an ideal gas is taken through the process ABC. You need to find out the total work done on the gas. So how to proceed in this one? This is a process where temperature is proportional to pressure. That means volume should be constant. So for a constant volume process, what is the work done? W should be equal to 0. Now for the second one, this is a constant temperature process. For isothermal process, work done should be A naught T ln P initial by V final by V initial, or you may write that P initial by P final. So N is how much? N is 1, or T is temperature 2 T naught ln P initial is 2 P naught by 4 P naught. So that should be ln 1 by 2, that is minus 2 T naught ln 2 should be your answer. Option C. The answer will be minus 2 T ln 2. Now moving on to question number 6. So in this question, a 15 gram mass of hydrogen is there, nitrogen is there, included in a vessel at temperature something. Amount of heat transfer to the gas so that the RMS velocity of the gas molecule is doubled. You know that Vrms proportional to T, so Vrms 1 by Vrms 2 should be equal to root over T1 by T2. T1 is 300, T2 is T, so T2 is coming 1200 Kelvin. Now for nitrogen, it is 5R by 2. So Q is equal to NCB delta T. N is 15 by 28. CB is 5R by 2. Delta T is this much. So as you need to apply NCB, why you need to apply NCB delta T? Because it is in enclosed vessel. Enclosed vessel means volume should be constant, so you need to apply CB. And R is given in mole, so this should be NCB delta T, not MCB delta T. This we can't apply because R is given at per mole. Just put the values, you will get around 10. So then this one should be your answer. Next this question. 3 rods of equal length are joined to form equilateral triangle. To form a triangle ABC with the midpoint of BC, distance away remains same for all small changes in temperature. Coefficient of linear expansion for AB and AC is same. There is alpha 2, but that for BC is alpha 1. Then question given is this one. There are 3 rods of equal length 1 meter. Equal length L are joined to form an equilateral triangle. This one. Coefficient of linear expansion of this AB and AC is given. This one is given. This is alpha 2. For BC is alpha 1. And you can assume that this length is L. So for this one, how to do? If this is alpha 2, then you may write that at any time, at any temperature T, all the dimension increased, and you may write this one as, and this one as plus alpha 2L delta T. This is L into alpha 1 into delta T. Now in the question given as this L is remains same irrespective of the temperature. So if this is remains same, initially it was L equal to root 3L by 4, because all these were length L, so this is 60 degree. So if this is 60 degree, L 3L by root 3L by 2. Initially this was the length, and final length is, I don't know the value of theta over here, so you may write as minus
by 2
by 2 should be equal to root 3L by
4.
now just square on the both side. So L square is taken common. 1 plus, this is just apply binomial theorem because alpha, value of alpha is very small, and here also L square by 4, apply binomial theorem. Okay, L by 4. Now just you need to solve this one. So here L square and minus L square by 4 in the left hand side, right hand side is 3L square by 4. So this will cancel out if you solve this one. Now the final result is 2 into alpha 2 into L square delta t should be equal to L square by 4 into 2 into alpha 1 into delta t. So this 2 cancel out, L square cancel out, del t cancel out, alpha 2 alpha 1 by alpha 2 equal to 4. So alpha 2 by alpha 1 equal to 1 by 4. That's your answer. In this question, there is an ideal gas through the cycle ABCA. The net heat supplied by the cycle in the gas is, the whole cycle is 5 joule. Then you need to find out the work done. So for a full cycle, du is 0, dq is supplied to the gas, so it should be positive. dw cycle is wab plus wbc plus wca. wbc should be 0 because that's a constant volume process. Yeah, this is v, this is p, and for wab there should be p into delta v. P is given 10, so this is 10, delta v is 1, so 10 into 1 to 2, so 10 into 1, that's wca. So wca is minus